These are the answers to the practice test answer pages 1 through 13. Kinematics is a study of motion without reference to the forces that cause the motion. So your answer for number 1 is going to be B. Number 2, a projectile is any moving object upon which the only force or active force is going to be D, gravity. Number 3, neglecting air resistance, the horizontal component of velocity. A projectile that moves along the path of a parabolic curve will increase. So all that's asking you is how is it going to increase, decrease, remain constant, or fluctuate on the parabolic curve. So if you have a curve plotted like this, the horizontal distance is going to be this way. So if we launch a projectile this way, the distance is going to just continue to increase. Number 4, neglecting air resistance. Which of the following trajectory angles measured from the horizon will result in the greatest horizontal distance traveled by a projectile? That's going to be, for this answer, 40 degrees. The angle that is going to produce the greatest distance traveled is actually going to be a 45-degree angle. So if you don't have a 45-degree angle, the closest thing that you have to it in this case is going to be 40 degrees. If you have a 90-degree angle, your projectile is just going to go straight up and straight down. 10-degree angle, it's going to be real low. 70-degree angle, a lot of people will try to pick this, but it's actually going to come down more in a straight line, whereas if you have a 45-degree angle, it's going to have more of an elongated curve. The actual performance of a ballistic device. This is asking you the 2 initial trajectory angles for ideal distance. So ideal up here is the solid line. So you need to find the angle where it corresponds to 6 feet. So right about in here, I have 6 feet, and it's going to touch the blue line at approximately 10 degrees. You travel all the way over to the side, same thing. Right here where 6 feet is going to intersect the blue line, that's going to be 80 degrees. So angle number 1 is 10 degrees, and angle number 2 is 80 degrees. What would the actual initial velocity be if you're using the 30-degree firing angle? So if you're using the 30-degree firing angle, you first need to set up the initial velocity equation. So initial velocity, VI, is going to be equal to the square root of your negative g times x over the sine of 2 theta. So now you need to go ahead and plug in your values. So again, substituting here, VI is going to be equal to the square root. In this case, negative g, we're going to be using negative 32.15 feet. So a negative and a negative actually is going to equal positive. 32.15 multiplied by x, which is going to be, in this case, 12. The reason it's going to be 12 is because you're looking at the firing angle. The firing angle is given 30 degrees. So right here's the 30 degrees. But you also need to make sure that you read the question that says actual. So in actual, you are going to have to come up right about to this point here. It's the dotted line, it's not the solid blue line. So it's the dashed purple line. So the 12 is going to be where your 30-degree angle matches up. So that's why this number right here is 12. Then you're going to just go ahead and divide that by the sine of 2 theta, which is 2 times 30 degrees. And once you go through and substitute and solve all that out, your initial velocity should equal 21.10 feet per second. Now, this next one, where it says number 6, study figure 3 and answer the following questions. What is a motorcyclist's initial horizontal velocity? That is actually given right here. So on this one, the horizontal velocity is given. It's hard to read, but it's 36.99 feet per second. Letter B says, what was the horizontal distance between the takeoff and landing point? So all they're asking you is how far did he go? So you're solving for X. So in this case, using your equation, it's a given equation. X is going to be equal to my initial velocity squared multiplied by the sine of 2 theta over your negative g. Substitute and solve. My X is equal to my initial velocity of 36.99. We got that from answer A. Squared multiplied by the sine of 2 theta. Sine of 2. And over here it says, using the takeoff angle, we're going to try to find 35. Okay, so the sine of 2 theta, in this case we're going to use 35. It tells us right here our initial takeoff angle, so 35 degrees, and again that's all divided by 32.125, and that is given right here. So solve it out. You should come up with a horizontal distance of 39.99 feet. So A is 36.99, B is 39.99 feet. Control systems. If electrical wires are connected to ports 1 and 2, the switch is going to be wired normally what? So if you look close here, they're saying if a wire is plugged in there and there at the same time, what type of switch is that going to be wired as? So if you look up here, this picture, this diagram they've got given here, if you're just plugging into ports 1 and 2, this switch is going to be to the closed position. So that is going to be a normally closed switch. If it was in ports 1 and 3, then it would be normally open. Which of the following digital control devices device processes the input information from the sensor? So which one is going to take and process? The actual word is in the answer, microprocessor in this case. A variable resistor, that's just going to give you a different value. That's an electrical value. The other two just don't even make any sense. Number 3, the difference between an open and closed loop system is that open loop systems do not have feedback. So an example of an open loop system would be like a washer and dryer. When you put your clothes in the washing machine, if you do not have one of the brand new washing machines that has sensors and all those things built into it, I'm talking about the regular old washing machine, you put your laundry in and you start it, you let it run, it's going to run its course and stop. Same way with the dryer, you turn the knob to the dryer, set it to 60 minutes or however long you think you're going to need. All that dryer is going to do is run for 60 minutes. It's not going to take any information. It's not going to have any input. An example of one that is going to have input, a closed loop system, would be, for example, a sensor on an automatic door. The automatic door is not going to open until somebody stands in front of it, so it's going to have an input. So the big difference between open and closed loop systems, one has an input, the other one doesn't. Number 4, which of the following devices can be used to help a computer identify the color of a glass marble? So in the color of a glass marble, this is going to be B. It's going to be a photoresistor. The photoresistor is actually something that is used with the Fisher Technics device. Our VEX stuff, we did not have a photoresistor. We did have a light sensor and a line follower. That's the closest thing to that. Statement that best describes the design process for a product. So this is in the engineering design spectrum. This is going to be C, a process that's repeated several times. The reason it's C is because A is a complex process that requires computer models. Yes, it does require computer models, but that's not the best answer. A process that's performed once, that is obviously not going to be true. A process that guarantees success. You're not always guaranteed success with this. So it's repeated several times. Number 2, maximum cost, weight, and volume are all examples of the constraints. So if you look at your bridge competition, you had constraints on how much material you could use. You were limited to 15 balsa sticks. The area and volume, we put constraints in terms of the dimensions of the lumber that you could use and the width and the height. So those are all constraints. Number 3, the first step in the design process is always going to be to define the problem. 4, skills that are critical for good engineers, all of them. They need to be able to sketch, communicate, and technical write. Number 5, the first thing is actually creating fire. That's the first engineering achievement. Number 6, engineering versus engineering technology. Engineering has a greater focus on theory. When you're talking about technology, that is going to be the people that actually work more hands-on with the actual parts. When you have engineering, you are more concerned with the numbers and the proof behind it, not necessarily getting in there and fixing something that went wrong. Number 7, a freehand drawing is obviously going to be a sketch. Number 8, the design is a plan or process that is used to guide development and solution of problems. And number 9, 4 causes are going to include operator error or misuse. So in this step, you are asked to plug in answers A, B, C, and D in the 4 openings here. After you define the criteria, that is going to be D, investigate and research. After you investigate and research, generate solutions, and then you're going to pick one of those solutions, so that's B. You're developing that solution in the next step. The following step is going to be where you begin modeling and prototyping. After that, you're going to test and evaluate, and then once you test and evaluate, you're going to have to go through and kind of start the process over. You're going to figure out that your design was not perfect the first time, so you're going to have to redesign and improve. Which statements go with the statements below? On page number 6, a team of principals and engineering students spent half the class period debating which of their initial sketches would be worth pursuing. They're actually going through step number 5 of the design process. So step number 5 is choosing a solution. The next one is going to be 8. So in that step, they are testing and evaluating. This next example is from step number 9, which is redesigning and improving the solution. And the last one is number 3, which is research and investigate. Heat transfer of energy from one place to another and occurs naturally. Which one is not a natural heat transfer? Refrigeration is actually not a natural heat transfer. Number 2, that's going to be from the sun to an Earth satellite. Number 3 is going to be C. Heat transferred by conduction, so the stovetop and the water. Number 4 is B. Plastic is going to be a good insulator. Number 5 is A. Increase the R value. R value is what's going to be associated with insulation. So higher the R value, the higher the insulation. Number 6, that's going to be Newton's, the second law of thermodynamics. And number 7, this is going to be an example of convection. We're talking about materials. This is where you're going to have to go back to your deflection, beam deflection, and modulus of elasticity, moment of inertia, all of those equations. So you're going to have to pull those out and have those ready. So in number 1, student weighs 150 pounds and standing on a beam which spans 96 inches, and modulus of elasticity is 1,200,000. The moment of inertia is 12 to the 4th. What you need to first do is use the equation of beam deflection. So in beam deflection, that's this one. That's the delta change in max is going to be equal to that FL cubed over 48 EI multiplied by E and I. So in this case, you are going to be using the F is your force, which is the weight of the person. That's 150 pounds, multiplied by the distance, which is going to be 96 inches cubed, and you're going to divide that by 48. 48 is a constant. The E is your modulus of elasticity, so that's 1,200,000, and multiply that by your moment of inertia, which is given as well, so that's 12. You plug that in, everything should come out to 0.192. So that board is going to bend 0.192 inches under the 150 pound load. Number 2, the moment of inertia. This is where you're going to have to use the calculation. I'm going to go over here. This is the IXX. IXX stands for moment of inertia. That is equal to your base multiplied by your height cubed. The base and height are extremely important in this part, to make sure you get the right one, and that's over 12. So plug in your values. IXX, so moment of inertia is equal to our base. So in this case, it is 1.5 inches. That's multiplied by my height. So in this case, it's 5.5. Make sure that you're only cubing the 5.5, because that will make a difference. And divide that by 12. So my moment of inertia is going to be 20.79. So in this one, you're going to pick option B. Number 3, the modulus of elasticity of a beam is 1.5 times 10 to the 6. So that's the same thing as 1,500,000. 200 pound weight is placed into the center, 4 feet from each end. So this is where most people messed up. So if you have a board and your center point is 4 feet from each end, the whole length of the board is going to be 8 feet. So that's where a lot of people made the mistake here. So it's the same equation as up here for number 1. So change of max. So deflection is going to equal same thing, FL cubed over 48 EI. Plug in your values. So we have a force of 200 pounds. So 200 multiplied by the 96 cubed. 96 cubed comes from 8 feet multiplied by 12 inches. That equals 96 inches. So that's why you're using 96 there. And then divide that by 48 EI. 48 again is a given. That's a constant. The E in this case is 1.5 million. And then your I, moment of inertia, is given as 20.79. So you're using 20.79 from the previous equation. So the answer to number 2 is going to be right here. So that's where the 20.79 comes in. Your answer should be for number 3, once you calculate all that out, 0.118 inches. So that's going to be option A. And number 4, the centroid of the triangle. You got to remember, when you're doing a triangle, it's a third base and third height. So whatever the base is, over 3, whatever the height is, over 3. In this case, the base is going to be your x value, so it's 1 divided by 3, and that's going to equal 0.33. And your h is going to be your height, that's your y value, so h over 3 is equal to 2 over 3, which is going to give you 0.67. So your answer is going to be C, 0.33 and 0.67. Number 5, that diagram is just of a line graph. And number 6, the centroid of the circle, it's 15 inches. So if you're using an XY plane, you're starting here at 0, 0. So half of the circle this way and half of the circle this way are going to be the same. So it's going to be 7.5 inches X and 7.5 inches Y. Moment of inertia is going to calculate the amount of deflection that occurs in structural beams, so that's A. The following material that has the most resistance to extreme heat, that's going to be ceramic. Number 9 shows a 100-pound normal force being applied, a 12-inch long by 10-inch diameter cylinder. What's the resulting compressive stress in the cylinder? So to find this, you're going to have to first and foremost find the area. So the area of a round object is going to be pi r squared. So you need to look at the number right here. This says 10-inch diameter. You're not even going to worry about this 12. That's just in there to throw you off. So pi r squared, in this case, your radius is going to be a 5 because this is a diameter of 10. So pi times the radius squared, that's going to give you an answer of 78.5. And what you have to do, you have to take the force. So the stress is going to be equal to force over area. So force over area in this case is 100 pounds. The area is 78.5. That's going to come out to 1.27 psi. So the answer is D. Number 10 is going to be a drill press. 11 is forging, application of heat and pressure to reshape. 12 is returning to its original size and shape, so that's B. 13 is going to be ductile. What's the area of object number 3? So in this case, what you have to do to find the area is just multiply these two numbers. So length times width, 22.4 multiplied by 46.8 is going to give you 1048.32. What's the vertical distance from the reference line to the centroid of the object? So this line right here is the reference line. So what they're saying is if this is an XY plot, so X, they're going this way, how far up this object, so just object number 2, how far up this object is the centroid. So for a square object or a rectangular object, it's going to be halfway in between this way and halfway in between this way. All it's asking you is for the vertical part. So all you do is take 132 divided by 2, and your answer is going to be 66. Number 16 here, calculate the force of the sample experience at the proportional limit. So first and foremost, you've got to identify the proportional limit. So in this case, the proportional limit is going to be here. Okay, proportional limit is where it's going to be able to flex back. So what you're going to have to do is take your information here. The area is 0.2. So you've got a number of 40 here. Times 10 to the third. So for this equation, right here, 40 times 10 to the third divided by 0.2. Your answer is going to be, for A, 200,000 psi. For B, it says starting at the origin, ending at the proportional limit, calculate the modulus elasticity. So all they're doing there is trying to find the slope. Modulus elasticity is just a slope. So starting at the origin right here, which is 0, 0. So that is going to be x1 and y1. And then x2 is going to be how far over this way. So my proportional limit is identified here where this red dot still is, and it looks like it's going to line up right down here with the 5. So my x is 5, and that's going to be times 10 to the negative third. I get that from here. And my y is how far up, so that's just going to be my 40 again times 10 to the third. So now this is x2 and this is y2. To find slope, all you're doing is taking y2 minus y1 and dividing that by x2 minus x1. So what that's going to give you is essentially 40 times 10 to the third divided by 5 times 10 to the negative third. And that is going to equal, I'll draw it up here, 8 million psi. Again, your answer for A is 200,000 psi. Your answer for B is 8 million psi. Point A, that's going to be your yield point. So when you have the yield point, that's where things are starting to deform plastically. They're not going to be able to go back to the original shape. So everything down here in this section will go back to its original shape, like a rubber band will stretch back. Once you get to the yield point, you go past that, it's going to deform. B is going to be your ultimate force. So that's your ultimate, or your tensile strength. The ultimate tensile strength is what most people will call that. And then there's also letter C. Letter C is if the change in force of direction of the diagram is 100,000 pounds and the change of displacement is 0.10 or 0.1 inch, what is the modulus of elasticity? So all you're doing, in this case, you are just going to take the 100,000 and divide that by 0.1 inches. So 100,000 divided by 0.1 is going to give you the modulus elasticity of 1,000,000 psi. Last page. The problem asks you to break up this shape into 3 different shapes. First and foremost, you got to find the area of the rectangle. So the area of the rectangle is going to be here. So 17 multiplied by 8.5, that's going to be 144.5 square inches. Then you're asked to find the centroid for the x value. So centroid of a square object is going to be half base and half height. So half of 17 is going to be 8.5. Half of 8.5 is going to be 4.25. Top left triangle area. Area of this triangle is pretty simple. It's a right triangle. So if this was a square, it would be 8.5 multiplied by 8.5. And then it's half of that. So the area is going to be 36.125. And you can go ahead and save yourself a step down here. For the right triangle, same thing. Area is 36.125. So the x value from the centroid. So what you have to do is you have to look at it as, again, just an XY plot. So starting from over here at the origin, how far this way and how far this way is the centroid. So half of 8.5 is, or excuse me, for centroid, you're doing a third base and third height. So on this one, if you have a distance of 8.5 here as your base, so remember base over 3 and height over 3. So in this case, for the top left triangle, your base is 8.5 divided by 3. That's going to give you a centroid of 2.88, or excuse me, 2.833. And then your y, this is not just 8.5. This is from here up is 8.5, and then from here to here is 8.5. So you need to also break this down and say that this part here, the centroid is going to be somewhere in here. You're going to locate that, and if you make the mistake of just doing 8.5 divided by 3 here again, that's going to give you an incorrect answer because it's based on an XY plot. So it's actually up at this point. It's at least 8.5 inches multiply or adding the 8.5 divided by 3. So your y is going to be 11.33 for this one. Top right triangle is the same way. However, same mistake a lot of people make. They forget to add this 8.5 to it and this 8.5 to it. So the centroid from the 0, 0 origin is going to be over here and up. So you cannot forget to add 8.5 automatically to your base over 3. So that is going to be equal to 14.16 in the positive direction. Same thing with the y. This one's actually already done up here. It's going to be your same answer. Your y value is still going to be 11.33. The area of the complex shape, all you do is add up the 144, the 36.125, and the 36.125. So your area is going to be 216.75 square inches. Your x is going to be a little bit more difficult. Or your y is actually going to be more difficult. The x is actually pretty easy. So if you would take and look at this object and you would kind of break it down this way, your x value is this way. So all you have to do is find this center here. So if this whole thing is 17 inches from here to here, all you have to do is find half of 17. So your x is actually pretty easy for this one. It's only 8.5. So somewhere along the center line in here, the centroid is going to fall. The hard part is the y. When you have to find the y, you have to go back to your equation. When you have a complex shape, it's a sum of all of the y centroids multiplied by the area of the entire shape divided by sum of the area of the entire shape. So what you're going to have to do is, first and foremost, is you're going to have to figure out these top numbers. So the sum of all of these together. So to find this, you have your y's multiplied by your a's. So in this case, you have numbers here, here, and here. So you're going to have to do 3 of them. So your first one is 144.5 multiplied by 4.25. 144.5 multiplied by 4.25. That's going to give you your first value on the top of 614.125. Okay, that's one answer. Now you need to do the next one. It says the top left triangle. So the area of that triangle is only 36.125, and you're going to multiply that by your y value there of 11.33, and that's going to give you an answer of 409.29. And of course, your answer for the next one is going to be the exact same. So the 409.29 is the exact same situation. So what we would do now, we would go back to this equation. Y is going to be equal to the sum. So the sum is 614.125 plus 409.29 plus an additional for the second triangle, 409.29, and that's all going to be over the sum of your area, and your area of the complex shape came from here, 216.75. Once you calculate that out, your y value for the complex shape is going to be 6.61 inches. So my answer over here is 6.61. So what that means is, over here, my centroid for this shape is going to be located at my x of 8.5 and on my y of 6.61. That's what this point is here, based upon an XY graph. That's it. Make sure you guys ask me for any clarification that you need. Feel free to advance the show as fast as you need. Make sure again that you ask questions, and the next video will be posted shortly.